Okay, page 548. So you're doing the even numbers 2 through 24. All right. Even though the instructions tell us something different on number 2 through 8, it says graph each equation by plotting points. 9 through 16, use symmetry to graph each equation. 17 through 24, use symmetry, zeros, and maximum R values to graph each function. You're going to do them all the same way. You're just going to plot points. The graph paper that I made for you has a little table down here on the bottom that you're just going to copy over from this one right here when it pertains to whatever function it is that you have to work with. Okay, for example, number 3 says R equals 1/2 cosine of theta. Alright, so I'm going to write that up here at the top. R equals 1/2 cosine theta. Actually, I'm going to write it down here at the bottom too. What I'm going to do is I'm going to fill this table out first. R equals 1/2 cosine theta. I'm going to utilize this table right here. Right, here's cosine. So what I'm doing is, in this function, I'm just cutting all of these values in half, and then I will copy them down to the table here. Now, just round off to the nearest tenth. It's going to make it a whole lot easier for you when you go to graph these things. All right, so cosine. Let me get my paper ready here. Hope you all are doing well. I do miss you, and hope that we can be back together pretty soon. I don't know any more than you know, so we'll just see how it goes. All right, starting at pi over 0 here. Cosine is 1, half of 1 is 0.5. Moving on to pi over 6, half of 0.866 is 0.433. So let's just round that off to 0.4. Pi over 4, half of 707 is 0.35. So we'll leave that as 0.35. Half of 0.5 is 0.25, and so on. All right, so you'll get these values. Some of them will be positive, some of them are going to be negative, whether it's a lemicon or whether it is the other shape that they talked about, a rose, makes no difference. Cardioid or rose or lemicon, you're going to plot points and you will connect them as you go with smooth curves. How are you going to plot them? The first point is 0.5. That means go over to the 0 rotation, which is right here, and go up 0.5. Right there. There's the first point. The second one in the table is pi over 6, 0.4. So go to the pi over 6 rotation and go up 0.4. So it's going to be less than this one. So about right there. Maybe I should have drawn the vectors on here. At the next rotation is pi over 4. Go up 0.3. Pi over 4, 0.3. So it's going to be even smaller than that one. Let me readjust this. Pi over 6.4. Disregard that one. And then pi over 4.3. There we go. Start connecting these with the smooth curve. Okay. Pi over 3, 0.25. Yep. pi over 2. When you cut 0 in half, it's still 0, so connect it right there. Now these start over again, actually going backwards, and now they're negatives. So 2 pi over 3, which is way over here. And then from there, 0.5, half of 0.5 is 0.25. It's going to be reciprocal with this one right here. So go over to 2 pi over 3. There it is right there. Now from the origin, go negative 0.25. That means go backwards. Instead of going to your rotation mark, you go backwards from that. So right here. And then it's going to be 0.35 again on 3 pi over 4. Negative. So right there. And then it will be negative 0.4 for the next rotation. Right there. And then it will be negative at pi negative 1. So negative 0.5 right here. Okay. Now if we continue on with these, what we're going to find is that they're going to start repeating themselves. 7 pi over 6, and at 7 pi over 6, negative 0.43. Okay, so that's this point right here. So actually, that graph is done. I know it looks tiny, but it is done. All right, so this is the process that you're going to use. You'll use this table to get the original values for cosine, sine, secant, or cosecant, whatever the function is. Take the value, plug it in for that trig ratio. If it's 3 plus cosine of 4, cosine of theta, 3 plus cosine of theta, here's cosine. All right, so at 0, it's going to be 3 plus 1 is 4. At pi over 6, it's going to be 3 plus 0.866, so 3.866, and so on. Use these values. Plot the points, connect them as you go with a smooth curve. Okay, in our calculator, I would highly suggest that you graph these first in the calculator. Take a look at what they're supposed to look like, and it will make your orientation just that much easier. You'll understand what the graph looks like and where it is that you should be going on the graph. You need to set the calculator up. Push the mode button. You need to select radian, and then you also need to select polar. Right there. If you will do that, then go to y equals, type in these functions just the way that they are on your paper, push graph, and it's hard to see, but right there is our graph. If you zoom in, there it is. Mine's kind of ugly, but it looks like that one right there. And I know that I've done it right. The more complex they get, the more helpful this is going to be for you. 3 plus, I don't know, sine of theta, or, sorry, let's do 3 plus 3 sine of theta. Zoom out. There it is. Your graph should look somewhat like that. For secant and cosecant, I went ahead and I put those on in the table, because in order to do secant or cosecant in the calculator. Those are the inverses of sine and cosine. Let me find a sheet of paper I can write on. To get secant values, secant is the inverse of cosine, so it's 1 over cosine. So in the calculator, to get those values for the table, for secant, for 0, I had to do 1 divided by cosine of 0, enter. For pi over 2, I had to do 1 divided by cosine pi divided by 2, enter. And that's how I got the values for the table. Cosecant is the reciprocal of sine. So it's 1 over sine. And I did the same thing. To get the cosecant values, it's 1 divided by sine of theta, sine of 0 to get that one, 1 over sine of pi divided by 2, and so on. So I've done that for you. You shouldn't have to worry about that. Just use the table, plot the individual points. These are polar coordinates, so you do a rotation to whatever the angle measure is, and then you start at the origin. You go up towards, let me just show you on here. So you're going to plot the point 3 pi over 2. Okay. This is your measure of rotation. So you would, from the origin, rotate up to pi over 2. All right, so I'm going to put my finger there. This is the vector that you're working on. This is a positive number, so you go to that measure from the origin 3 units. 1, 2, 3. And there is the polar point 3 pi over 2. Okay, so let's say that it is 3 pi over 2, negative 2. Negative 2, 3 pi over 2. So you're going to rotate all the way around to 3 pi over 2. Here it is. 3 pi over 2. Okay. Now, this is the distance from the origin, negative 2. If it were positive 2, you would head in the direction that my finger is tapping at right here. From the origin, you would go this way 2. But it's negative 2. That means start at the origin and go the opposite direction 2. There it is. That's the point, negative 2, 3 pi over 2. All right. This is new, and it is different. You can do it, though. I know you can do it. Read that section in the book. Look at the examples. Read the instructions I left for you on your piece of paper. If you just get absolutely confused, call me. Send me a text message. Send me an email. Whatever you need to do, I'm here to help you however I can. I know you'll do great. Remember, all you have to return back to me is your work. The notes you keep for yourself. Thanks. Bye.